Okay, I said I would do some of these problems for you, and these problems are really getting us ready, or we're supposed to get us ready for buffers and understanding buffers. And in these types of reactions, what we generally have is we have a strong acid or a strong base reacting with a weak acid or a weak base, and at times we will throw in there some sort of salt. And so it's important that we understand the chemistry that's going on in here, and in order to do that we need to understand what species are going to be here and what types of concentrations. That's going to be given to us as well. So what I like to do in these problems is right at the beginning what's in there. Okay, so we know that HNO3 HNO3 is going to be a strong acid. Glad that sneezes in there for posterity. Okay, and we know that a strong acid is always going to break apart, and in water that's going to leave us H3O plus, plus it's going to leave us the NO3 minus. It's important to remember too that NO3 minus you might think is a conjugate base of this acid, but it's important to remember that when you have a strong acid, its conjugate base really doesn't have any acid or base properties at all. Because in this case it won't have any basic properties because this is a very, very completely strong acid. Okay, so we're going to have H3O plus and we're going to have NO3 minus, plus we know from this original problem that we're going to have some ammonia in there as well. Okay, some NH3. Okay, that's at the beginning, and I also need to keep in mind that I have 1.3 moles of HNO3 and I have 1.3 molar of a 1 liter solution. Okay, it's convenient that they give us 1 liter because that equals 1.3 moles. It's moles per liter, molarity is. So I have 1.3 moles of NH3, I have 1.3 moles of this really strong acid. So these are going to react together at equal molar amounts and go to completion. Okay, so let's go ahead and write the chemistry that's going on. HNO3 plus NH3, so that's a strong acid plus a weak base, at equal molar amounts is going to give me NH4 plus that NO3 minus. Okay, so that's the chemistry that's going on. All of this is being consumed because you have equal molar amounts of this. All of the acid, all of the base are going to be consumed. Okay, and it's going to leave us this NH4 plus and this NO3 minus, this nitrate. There's nothing else that is in there because all the acid, all the base goes away. Alright, so we know that NO3 is going to be an other, and how do I know that? Because it is the conjugate of a strong acid. So that is going to be spectator, it's not going to do anything, so that goes in the other. Okay, and we have ammonia, or we have NH4 plus, the ammonium ion here. Well, it tells us here, it might be useful to remember that NH3 is a weak base, and so its conjugate acid, NH4 plus, is going to be a weak base. It is going to have basic properties, and in fact, this solution is, even though all the acid and base are being consumed in the initial reaction, it's going to leave this conjugate acid here. Oops, I put it in the wrong place. It's going to leave that conjugate acid right here. Okay, and this solution is going to be slightly acidic because of that. It's not going to be a pH of 7. Alright, so that's how I would do that first problem. I realize what's in there initially. I take account for any chemistry that's going on. I make sure I look at the concentrations. And once I do that, then I can assign what species are going to be there. Alright, let's move on to another one here. Okay, so we have, a strong base. We have 2.2 moles being added to a 1.1 mole per liter, so 1.1 moles because there is 1 liter, solution of HF. HF is a weak acid, and KOH is a very, very strong base. Okay, so when I put this into water at the beginning, I know I'm going to have some K plus. I know that I'm going to have some OH minus because strong bases completely fall apart. And I know that I'm going to have some HF. Okay, so again, remember that the basic part of that is OH. That K plus is just a spectator. because it would be considered perhaps a conjugate acid, but because it's the conjugate acid of a strong base, it has no acidic properties whatsoever. So my other is going to be K plus. And if you have a hard time remembering some of that, when you see things like K plus in these problems, Na plus, those are probably the two bases, those are always going to be others. Cl minus is always going to be an other, I minus is always going to be another, Br is always going to be other, Br minus, NO3 minus is always going to be another. That's because these are all conjugates of strong, very strong acids. Okay, so that's just a reminder. So let's go back to this problem. Okay, so I have these initially. Well, I know that this strong base is going to react with this weak acid. Okay, so not only, so let's write the chemistry. So I have KOH, or just the OH, plus this HF. Okay, that is going to then leave me my F minus, plus there's going to be some H2O come out of this, and plus there's going to be that K plus as well. Okay, so that's what the chemistry is telling me that's in there. Alright, now it's important to know that because HF is there in a less molar amount, all that's going to be consumed. That's gone. But that's still going to leave you some excess KOH. Okay, so that's going to leave us some excess OH minus. And notice here that you generated some F minus. Well, F minus is the conjugate base of this weak acid. Okay, so it's the conjugate base of that weak acid. And so I have a base left, this OH minus. I have some F minus left, and let's see if I have anything else. Well, got that K plus. I already put that down there. That's all the chemistry that I see going on here. Okay, so my bases here are going to be the OH minus, and it's going to be the F minus. Alright, so once you get into the habit of doing these, I think you can do these. You just got to think of everything that's going on here. Alright, let's see if we can get some other things here. Okay, so in this case, let's look at the problem. I have HNO3, which is a strong acid, and I have NH3, which is a weak base. Okay, and notice that I have 1.7 moles of HNO3, and I have 1.1 moles of the weak base. Okay, so let's go ahead and write up here that H3O plus is going to form in the water. I'm going to have the NO3 minus, so that's my nitric acid that I'm taking care of right there, the HNO3. And then I also have, the only other thing in here is I have that weak base. Well, I know that this strong acid is going to react with that weak base. Okay, so you can write this however you want. Let's just go ahead and write HNO3 plus this NH3 is going to give us NH4 plus that NO3 minus. Okay, well, we know that since nitric acid is a strong acid, that NO3 minus doesn't have any acid or base properties, so it's going to be NO3 minus is going to be an other right there. Okay, notice how though that our acid is in excess right here. Okay, and so that there's going to be much more of this. All of the ammonia is going to be consumed, and we're going to be left with this excess HNO3. Well, we already kind of did the chemistry up there, but it's important to know that that H plus is going to react with water to give you H3O plus. Okay, so when I look at everything, do I see any other reactions that are going on? I don't. Okay, so what am I left with? Well, I'm left with H3O plus right here. Okay, so that's an acid for sure. Okay, but notice how I also have in here this weak conjugate acid in NH4 plus. NH4 plus. I don't see any bases that are left over, and if there were bases, they would react with that H3O plus, and so I'm done with this one. Alright, so these are actually pretty simple. Let's see, if we have some others. Okay, this is a slightly different play on it. Alright, so we have here a very strong acid, and I have some NH3, a weak base. But now the acid, there's only 0.2 moles, but there's 0.9 moles of the NH3, okay, because that's 0.9 moles per liter, and we're in a 1 liter solution. Alright, so let's write down what's going on here. So I have that HCl, so I have some H3O plus. I always like reacting that with water at the beginning. Okay, and then I have some Cl minus. It's going to break apart. And then I have some NH3. Okay, so now let's go ahead and do the acid-base reaction where we have the HCl plus the NH3. Okay, that is then going to give me NH4 plus, this weak conjugate acid, plus some Cl minus. Well, you should already know by now after my explanations that this Cl minus is going to go in the other because it is part of that very, very strong acid. Okay, but now we know that all of the HCl is going to be consumed, but only some of the NH3 is going to be consumed, that weak base. That's because I know that there's 0.2 moles versus 0.9 moles of the NH3. So all of the HCl is going to be gone. We're going to be left with the NH3. We don't worry about the weak bases reacting with the weak acids. And so that is going to leave me then as a base. I'm going to have NH3. But I also have that conjugate acid that was formed, and that is going to be NH4 plus. I don't see any other chemistry that's going to happen as a result of this. Okay, so these are doable, my friends. Just got to practice them and kind of learn from these. All right, here's a little bit of a different solution. Okay, so I have some HI that's going to be in there, which is a very strong acid. I have some HCN, which is a weak acid, and I have some Na, some sodium cyanide, which is a soluble salt. Alright, so let's go ahead and write up here. Again, I like reacting that with the water just to get that in my mind, the H3O plus. I have the I minus, that's going to be in there. I have some HCN, that's going to be in there. And then I have some Na, because it's a soluble salt. There's going to be some Na plus, and there's going to be some Cn minus that's going to be in there. Okay, so some things to kind of quickly point out. We know that the I minus is going to be an other, okay, because it comes from that really, really strong acid. We also know that the Na plus is going to be an other, so I'm going to just account for those really quick here. Okay, and so I have in here, notice that I have some HCN, and the conjugate base of HCN is going to form some Cn minus. Alright, that does have basic properties, but notice I put the salt in there, so I'm adding some base in the form of the salt. Alright, a weak base, which Cn minus is going to react with a strong acid, and these might be some of the tricky ones to kind of pick out here. Okay, but notice I still have that strong acid, that Hi in there, and so a strong acid is going to react with a weak base, and so that's the chemistry that I see going on here. And so we have some Hi plus Cn minus is going to then give me some HCN plus I minus. Alright, so that's the chemistry that's going on. We put this weak base in the form of a salt, which is kind of how we make buffers, right? And so that's the chemistry that I see going on. Now let's look at the concentrations. We have 0.27 moles of HI, while we have 1.1 moles, because it's in a liter, of the cyanide, the sodium cyanide. Okay, so that means that this HI is going to be all consumed, leaving behind some Cn minus. Alright, so let's go and account for everything that's going to be in here. I still have that HCN has not been reacted with any base. Okay, so I still have that acid in there, some HCN. And for the bases that are going to be in there, then I still have some excess CN minus, right? Because it was in there at a higher concentration than the HI, so I have some CN minus. So I have HCN, CN minus, I minus, Na plus. All of the H3O plus, all of the acid is gone because it's reacting with this weak base that I put in there. Okay, so that's how I would tackle that one. See if I have one more here. I know you might want to skip. Alright, here's just a little bit of a different one. This is a strong base reacting with some sort of buffer system where we put in a weak acid and we put in its conjugate base in the form of a salt. Alright, so let's go ahead and write down everything that's going to be in there. So I have some KOH, so I'm going to have some K plus, I have some OH minus because strong bases dissociate completely. Alright, I have some HCN in there, which is a weak acid, and I'm putting in some sodium salt, some sodium cyanide salt, so I'm going to have some Na plus and some Cn minus. Well, again, you should already know that I'm going to put my K plus down in the other, as well as I'm going to put my Na plus, because they are the conjugates of strong bases. Excuse me, very strong bases. Alright, so I'm kind of accounted for all those. Alright, so do I have, sorry, not the Cn, the Na plus. I still have Cn minus. Okay, so what do I have in here? I have a strong base right there. Okay, so I have that, I go ahead and put the KOH just to make it simple. Okay, and it's going to react with that weak acid, the HCN. Okay, and that then is going to give me some Cn minus plus some water. Of course, the potassium is there just to hang out for a bit. Okay, so that's the only chemistry that I see. I have again, know that strong acids react to completion with weak bases, and strong bases, which we have here, react to completion with weak acids. Okay, so let's just look at our concentrations here. So I have 0.37 moles of the KOH, whereas I have 1 mole of both the HCN and the NaCN. So I know that the KOH, okay, so that OH is going to be completely consumed. It's going to be gone. There is going to be no OH in there. And so I'm still going to have some HCN because it's in excess. Okay, so I know that that's a weak acid, so I just go ahead and put that down, HCN. And any bases that I see in here, I do see a Cn minus. Okay, that is a weak base. And I think I've accounted for everything. So again, on the test, on quizzes, when you're doing Alex homework, these are good things. Actually, it's a good mental thing. I know we hate Alex a lot, but it's actually a very good mental exercise to go through, figure out what's in there, figure out the chemistry that's going on. So just a really quick review here. Know that strong acids are going to react to completion with all bases, weak and strong. Okay, and in these problems, it's usually a strong acid with a weak base. And then keep in mind the concentration. Know that strong bases are going to react to completion with weak acids. Okay, and I know my writing doesn't make a lot of clear sense, but I'm speaking, so you should be able to get it. And then know the spectator ions that are going to go on, and know that oftentimes you're generating just from the reaction itself the conjugates, and so go over these again, watch the video again, skip around if it's too long for you. I know it's a bit long, but I want to go through many different problems that you might encounter in these, and just do a good job of accounting and do a good job of chemistry. And again, practice. These are way doable. I think you can do it, and I think you'll do well on the test.